For this video, I'd like to talk about the solutions to systems of equations. So let's start first with what is a system of equations? And basically a system of equations is when you have two or more equations at the same time. And for this video and for many videos following this, we'll be specifically focusing on when we have two equations at the same time. So something like this. And when you have two equations at the same time, let's say you have y equals 2x plus 3 and y equals minus x minus 2. When you have these two equations at the same time, basically what's going to happen, and I'm just going to rough sketch each of these. So this might be the top equation, and let's say this might be the bottom equation here. And basically, when you have this system of equations, these two equations, when you graph them, they're just lines. These lines are going to intersect usually at one point. This is kind of the most common scenario, is where you just get one intersection point. So geometrically, this is what's going on when you have a system of equations. Now, it's also possible that these lines are parallel to each other, and you actually end up with no solution. And it's also possible that one line is a multiple of the other, so that let's say you have this line here, and then the second line will just be literally right on top of it, and they intersect at an infinite amount of points. So when solving these systems, there's actually three main methods that are used to solve them to find essentially this point, where these two lines cross each other. But for the sake of this video, we're just focused on testing whether or not a given coordinate point is the solution to the system. So we're given in this problem these two equations, minus 5y equals negative 5 and 7x plus 6y equals 7. And we're asked, is this point 5, 1 a solution of the system? So we have to test this point 5, 1. And remember, the first value is the x value and the second one is the y value. So if this is a solution of the system, then when we plug it into each of these equations individually, we should get back something true. Now, if we get something back that's nonsense, then we know for sure that this is not a solution of the system. So let's plug it into this bottom one first. We're going to plug in x equals 5, so 7 times 5, plus 6 times y is 1. And the question is, does this equal 7? But you can see this is 35, and then we're going to add 6 to that, and 35 plus 6 does not equal 7. It equals 41. So since it was not a valid solution of this equation, we can conclude that it's not a solution of the system. Though if you want, you can test it in the other one as well, but it honestly doesn't matter. If it doesn't work for one of these, then it's not a solution. The only time a point is a solution of a system is if that point is included in each of these lines. So it has to satisfy both of them. It can't just satisfy one of them. If it just satisfies one of them, it might be a point like maybe right over here where it's on one line, but it's not on the other line. And if it doesn't satisfy both equations here, then it's probably just some point out in the coordinate plane where it's not actually on either line. So if we test it in the other one, so let me use a different color for that. We'll do orange for that one. We'll do minus 5 times y, which is 1, equals minus 5. And this one's actually true. So this works. In fact, if you were to graph this line right here, this is just y equals 1, because you have minus 5 divided by minus 5, which is just 1. And so this would just be a horizontal line, actually, right about here. So this definitely does go through the point 5, 1, but the other equation does not. So let's move on and try some more problems. So we're given another system, y equals 2x plus 3 and y equals 4x minus 3. These two lines are going to intersect each other. And we just want to know, is the coordinate point 3, 9 a solution of this system? So 3, 9 is what we're testing. So x is 3 and y is 9. So that's the substitution we're going to make into each of these equations. So let's start with the first one. I'll just call this number 1. And we have that y equals 2x plus 3. So we're going to start with y and replace that with 9. So 9 is 2 times x, but x is 3, plus 3. And you can see that this is true because 2 times 3 is 6, and 6 plus 3 does equal 9. So that one worked. So now let's try the second one. We're going to plug into y equals 4x minus 3. So again, y is 9 equals 4 times x, which is 3 minus 3. And again, you can see this is true because 4 times 3 is 12. And when you take away 3 from 12, you do get back 9. So since this point worked in both of these equations, you know that this actually is a solution to the system. So in this case, it's yes because it worked for both of those. And let's try another one. So now we're testing the point 3, 8, and we're going to plug this in to both of these equations here. So in this case, x is 3 and y is 8. So I'll call this number 1. So for 1, we're replacing y with 8. So 8 equals minus 5 times 3 plus 1. And this one's not going to work because minus 5 times 3 is minus 15. And when you add 1 to that, you get back minus 14. But that's not equal to 8. So this one did not work, which means we don't even have to check the other one. But if you want to get some practice, you can definitely do that. So plugging it into number 2, you have that 8 is 3 times 3 minus 2. But this isn't true either because 3 times 3 is 9. And when you take away 2, you get back to 7. And 8 and 7 are not equal. So it actually didn't work for either of these. But again, you really only have to check one of them. And if it fails for one of them, then it's not a solution. It doesn't matter if it works for the other one. But in this case, it actually failed for both. So this is definitely not a solution of the system. So let's try another one. And in this case, we have the point 8, 3. So we're going to say that x is 8 and y is 3. And we'll call this one number 1. So let's plug it into the first one. So you have the opposite of x, so minus 8 plus 4 times y, which is 3. And does this equal 4? Well, minus 8 plus 4 times 3 is 12. And this is true because minus 8 plus 12 is 4. 4 plus 12 minus 8 gives you 4. So that one works. Now let's try the other one. Call this one 2. So for number 2, we want the opposite of x. So minus 8 plus 3 times y, and y is 3. And does this equal 1? So minus 8 plus 3 times 3 is 9. And that does equal 1. Minus 8 plus 9 is 1. So that one worked. So it worked for both of them. And since this was a valid solution to both equations, we know that this is the solution to the system. So if we were to graph these and figured out that they crossed at some point, this would be that point, 8, 3. So these two lines, when you graph them, this is not an accurate picture, but when you do graph these accurately, what you will find is that they will intersect at the point 8, 3. So this is a solution.